The conversion of cyclopentanol to 2-Methyl Cyclopentanol is a synthesis problem that we have actually seen in previous chapters, and one in which we can now use a shorter synthetic route with the use of an epoxide. Take a few minutes and see what you can do here. Looking at our starting material and our product, we find that both have a 5-membered ring with the same functional group. Now, we're not likely to keep that functional group throughout the course of the synthesis reaction, and so that is actually something of a bit distractor. What we do notice too, though, is that we have added an additional carbon to our product relative to where we started. And that involves the formation of a new carbon-carbon bond, which in turn implies the use of an organometallic. And if we notice that that new carbon-carbon bond forms not on the same carbon as the OH group, but adjacent to the carbon that ends up with a functional group, that might get us thinking about epoxides. And so if we think about that very last step, we could imagine using the organometallic with an epoxide such that we form this product directly. The organometallic could be methyl lithium or methyl magnesium chloride, and followed by H3O+, that would deliver our additional carbon, and the epoxide then that we would need to start with would be that derived from cyclopentene. And of course, to get the epoxide from cyclopentene, we would use a peroxy acid, peroxybenzoic acid or peroxyacetic acid, either one would be fine. To get that alkene from the alcohol, we'd need to use H2SO4, do a dehydration reaction. Now, I did mention there is a way to make this happen without using the epoxide, which is what we did in a previous synthesis or similar synthesis examples. And that would involve, rather than making the epoxide to react with the organometallic, to make the oxygen in the initial alcohol into an electrophile, specifically a ketone. Let's take a look at that. In this case, we still have the same new carbon-carbon bond to form, and so what we would do initially is to form that carbon-carbon bond on the carbon that will end up with a functional. Specifically, we would need to first convert that alcohol using PCC or some other oxidizing agent into a good organometallic electrophile, like a ketone. We then use our methyl magnesium chloride or our organolithium reagent, followed by H3O+. That would give us the carbon framework that we want, where we have our new carbon-carbon bond and our methyl group on the ring. It's just simply where the alcohol group is rather than adjacent to the alcohol group. Then we would do an old trick that we learned in Organic 1, which is to move a functional group like an alcohol over by using an alkene as an intermediate. So if we dehydrate the alcohol product using sulfuric acid, that will give us an alkene that we can then do the anti-Markovnikov addition of water across that double bond with B2H6 followed by a basic peroxide workup, and that will give us our target product. Now there is stereochemistry in both of these examples, which would then actually limit which reactions you would be able to use, but we won't get into that in this particular example.